In this problem, we're going to write the parametric equations that give the same graph. So this equation right now is in rectangular form with just x and y, and it's in general form where there are no denominators and it equals 0. The easiest way to put it into parametric form is to convert it from the standard form where it equals 1. So we're going to take number 25, and to convert it to standard form, we're going to use a technique called completing the square. We're going to group the x terms together, and we're going to group the y terms together. And then this constant term, the plus 4, we're going to move it to the other side by subtracting. So this whole thing will equal 0 minus 4, negative 4. And we're going to group the x and the y terms together with parentheses. Take that negative with the y. In order to complete the square, we need the coefficients of the squared term to be positive 1. So we need to factor out that coefficient. So factoring out a 2 from the x terms, we have 2 times x squared plus 12x. I'm going to leave a blank to complete the square. For the y terms, we have a negative 1 coefficient. We can only complete the square if the coefficient is positive 1. So I'm going to factor out a negative 1 out of both terms. So also out of the 4y. 4y divided by negative 1 is negative 4y. And then same thing we've done the x's, leave a blank. And this still equals negative 4. So to complete the square, we're going to create perfect square trinomials. Those are trinomials whose factors are the same. And to do that, we're going to take this middle term, divide it by 2, and square it. So half of 12 is 6, squared is 36, half of negative 4 is negative 2, squared is positive 4. Because we just added those numbers into the left side of the equation, we need to add them into the right side of the equation. So be very careful. We did not add 36, and we did not add 4. We actually added 36 times 2 because that number would get distributed to everything in the parentheses. So you're going to add 2 times 36. And we didn't add 4, we actually subtracted 4 because that minus sign gets distributed to everything in the parentheses. So now we're going to go through, we're going to simplify everything that we can. So this is now 2 times, and let's factor this x term, x plus 6 quantity squared minus y minus 2 quantity squared equals 2 times 36 is 72, minus 4 is 68, minus 4 more is 64. We're almost there. Standard form equations equal 1, so we need to divide everything through by 64. And so our final standard form equation, let's simplify wherever possible, is going to be x plus 6 quantity squared over 32, because the 2 and the 64 are both factored by 2, minus y minus 2 quantity squared over 64 equals 1. So this equation is still in rectangular form. It's in standard form. But this is useful because now we're going to use a trig identity to convert this to parametric form. And the trig identity that we have memorized is cosine squared t plus sine squared t equals 1. And there's some similarities between these two equations. They both have squared in them, and they both equal 1. The only problem is that our identity has a plus sign in it, and this equation is minus. It's a hyperbola. So instead, we're going to use a trig identity that has subtraction in it, and that identity involves secant and tangent. So when I look at this, I'm thinking, how could I get secant and tangent out of this? Well, I know that tangent is sine over cosine, and so I can force this term to be sine over cosine by just dividing by cosine, which you're allowed to do as long as you're fair and you do it to all the terms. So let's go through and divide everything by cosine squared t. So that makes this cosine squared divided by cosine squared is 1, plus sine squared divided by cosine squared is tangent squared, and 1 divided by cosine squared is secant squared. All conics equal 1, so let's get rid of this plus tangent squared by subtracting it. And we get that 1 equals secant squared t minus tan squared t. And I'm just going to rewrite it so that the 1 is on the right side like we're used to seeing. So what I want you to see is the similarities between the standard form equation and the trig identity. So now they both have something squared, they both have subtraction, and they both equal 1. So we can set the parts equal to each other. So we can say that secant squared t equals x plus 6 quantity squared over 32. And we can say tangent squared t equals y minus 2 quantity squared over 64. And we're going to solve each of these equations for x and y respectively. So for the x equation, I have divided by 32, so I'm going to multiply by both sides by 32. And I have x plus 6 quantity squared equals 32 secant squared t. I want to get x by itself, which means I want to get rid of this plus 6, but it's inside parentheses. And the parentheses are there because of this exponent. So the exponent is the next thing that we have to move. So to get rid of a square, we're going to square root. And the square root of 32, let's just leave that. The square root of secant squared is secant t. So one more step to solve for x, let's subtract 6 from both sides, and we get that x equals negative 6 plus radical 32 secant t. Now for the y equation, we're going to do the same steps. We're going to start by multiplying both sides by 64 because that's the denominator. So we have y minus 2 quantity squared equals 64 tangent squared t. And again, we're going to take the square root on both sides to get out of those parentheses. We do know the square root of 64, it's 8. And the square root of tangent squared is tangent. So then our last step is to add 2 to both sides. And we get that y equals, now we cannot add the 8 and the 2 together because this 8 is attached to the tangent 2 by multiplication. And thinking about the order of operations, PEMDAS, you would have to multiply before you could add. So it's just going to be 2 plus 8 tangent t. And those are parametric equations. Now there is a shortcut here that you can take if you remember this. If you go back up to your standard form, I want you to look at the connections here. The center is at 6, negative 2. The center is the value being added with the sign flip. Sorry, the center is at negative 6, positive 2. And that's why we have a negative 6 here, positive 2 there. And then we have our a and b. A and b are the square roots. So the square root of 32, square root of 32, square root of 64, square root of 64. And with hyperbolas, they're going to use secant and tangent. Secant goes to the first term, so secant goes with x, and tangent goes with y. So I could back up all the way. I don't actually have to do any of this stuff, so I'm going to erase it. I could actually back up all the way to this standard form, and I could just say, because this term is first, this x term is first, it has a secant in it, and the coefficient is the square root of the denominator, and then I'm going to put the opposite sign of the number in the numerator. Same thing for y. The opposite sign of the number in the numerator, because the center is at negative 6, positive 2, plus b is 8, because the denominator is 64, and the second term always gets tangent t. So if you remember your shortcuts, you can go straight from your standard form to your parametric form.